Welcome to the Chapter 5.1 lesson video. We're going to be talking about the number e. That's right, e is a number. All right, so we're going to talk about the number e and something called the natural log today, what they are. We're going to use them a little bit later in the chapter and get into a little more detail of what their purpose is. But today we are introducing the number e, okay? All right, so define what the number e is and how to use it. Really, this is going to change not very much in how we do things. So the good thing is if you feel good about what we're doing already, not much should change because this is just another number. All right, so let's go ahead and define it. The natural base is e. E is a irrational constant that is approximately 2.718 blah, 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 blah. We don't really care about after that. That's about it. It's kind of the same idea as pi. It's a number. It's a decimal number that never repeats. But this is a new one called e, and we're going to use it. It's used in a lot of modeling of different growth and decay type things like interest and nuclear waste and cell division, and we're going to see it come up a bit later in the chapter, but we're introducing it now. The natural log is a log with a base of e. So when you see ln of x, what it's really saying is log base e of x. Now, that's not how we write it. That's a little silly. We call it the natural log. All of our same laws from normal logs apply for the natural log and e. It's all the same stuff. So if you have the natural log of a equals x, you can change that into e to the x power equals a. Or if you have e to the x power equals a, you can change it into the natural log of a equals x. Before, if there was no base given, we said base 10. This is the one exception. If it's ln, then the base here is e. We will use e in exponential equations where we want constant exponential growth and decay, so modeling kind of real world change as things change rapidly and stuff in later sections here. But this is kind of just our first introduction to it. So really, all you need to know is it's a number. That number is about 2.72 or 2.718, and ln is log base e. Other than that, everything's the same. So as we do these problems, it really just follows the same things here. So ln of x equals y, that's really just log base. If you want to write it in real quick right here, you can. That's log base e of x equals y. So we could change this to e to the y power equals x. Same thing here, ln of x plus 2 equals 5. We can change this to e to the 5th power equals x plus 2. Right, we're just changing the form here. And then just to kind of keep us on our toes here, this is not log base e, not ln. This is log base 10 because it says log, not ln anymore. So this is 10 to the f power equals 7. So hopefully you see the difference here. Here, these were ln with nothing, so that means it's log base e. Whereas this last one was log, not ln, and so it was log base 10 when there was nothing. All right, these other ones, we can go back the other way. So when I see e to the w equals p, I can change this into the natural log of p equals w. And likewise here, I can change this into the natural log of 5 equals x plus 1. Same idea as all our other logs. It's log base e. ln is log base e to the answer. Old answer becomes and the old input becomes the new answer. So those kind of just switch sides. In log base e, we just don't really write that e in. Okay, let's keep going. All right, even our evaluation stuff is kind of similar. These two are inverse problems, so we can evaluate them. E and the natural log cancel each other out. Since we don't really know our powers of 2.187, that's kind of a random number. You don't really know what that is squared. We don't really see those too much except in this context. ln is log base e. If you want to write that right there, you can, log base e. So ln, log base e, and e cancel each other out. That would mean here we end up with just a 7. Another way you could show your work here is you could say e to the x power equals e to the 7th. So x is 7, right? So here it's just 7. Same thing here, e and the natural log are going to cancel each other out. There's one little extra step we have to do. We have to move this coefficient up to be an exponent first, though. So we're going to rewrite this as e to the ln of x to the 5th power. Now the log base e, the ln, and the e can cancel each other out, which will leave us with just the x to the 5th, which is our answer here. So the main idea is that if you have an ln and an e in the same thing, they can cancel each other out. They're inverses of each other. E and the natural log are inverses. Here, e and the natural log were inverses as well. We just had to move this 5 up first. So that way it was e to the ln, not e to the 5 times ln. We had to get that 5 out of the way. All right, and then last but not least, all of our equation problems that we learned in that last section still apply. So everything is still kind of the same. Here on the left side, we'll start with the one on the far left first. These are both natural logs, so I can combine them in the same way that I would combine other problems. Since that's a subtraction, I will combine that to be the natural log of x squared over x. And set that equal to 7. I'll simplify that inside. X squared over x is going to become the natural log of x equals 7. And then here I'm trying to get the x by itself, so I'm going to change this to exponential form. So I'll change this to be e to the 7th power equals x. So x is now by itself. So x equals e to the 7th power, which we can plug into our calculator to evaluate. So you'll pull out your scientific calculator, and you'll go ahead and you'll type in e to the 7th power, and you'll get that x is approximately, we'll go approximately, x is approximately 1096.63. All right, so there's your exact answer and your approximate answer. All right, our second problem right here, I have this e to the 5x equals 7. I want to be able to get rid of that e. So one thing I can do here, I could either take the log of both sides. That's one option. But because I have this e, I might take the natural log of both sides. So I'll go ahead and I'll say the ln of e to the 5x. And I'll also do the natural log of this side. The only reason I do that a little bit differently here is because the ln and the e can cancel each other out. So I'll be left with 5x equals the ln of 7. And then divide by 5 on both sides, get x equals the natural log of 7 over 5. The only reason I can do that here is because the calculators that you guys likely have also have a natural log button. So when you look at your calculator, you'll very likely also have a natural log button. Normally we don't do that for anything other than base 10 because we don't have most buttons. But since we do have a natural log button, we can do that. So we do natural log of 7 divided by 5. So we get x is approximately 0.39. Okay, so those are the answers there, or that is the answer there. And then this last one here, this last one is already set up kind of nicely. We have e to the ln of x squared equals 25. Just like this last one, the e and the ln are going to cancel each other out. They're inverses of each other. That'll leave us with x squared equals 25. Okay, so x squared equals 25, so we'll go ahead and we'll take the square root of both sides. So we'll get x equals plus or minus the square root of 25. And we'll take the square root of that, so we'll get x equals 5 and negative 5. Now, anytime we get two answers, we should pop it back in if there's a log and make sure that it makes sense. So the ln of 5 squared, that's going to become positive. That's good. And then even negative 5 squared is still going to become positive. So in this case, these are both valid solutions because when we plug them in, even the negative, when it gets squared, becomes positive. And so that's our final answer there. All right, that's it for our lesson here. It really just follows the same rules. Main thing to remember is that E is approximately, it's just a number, approximately 2.718. It's nothing fancy. If you see ln, it is really just log base E, nothing fancy there. And we're going to use E a little bit later. So that's why we introduce it now, and just to make you a little more comfortable with it. All the same rules are still applying. It's not much different than what we've been doing. If you have any questions, please feel free to reach out. Otherwise, I'll see you in our next live session. And until then, I hope you have a great day.